Hi friends, in this lecture we are going to discuss one component systems. So here when we consider the one component system, there are various examples of the one component system: water system, sulfur system, carbon dioxide system. So all of you know that when C is equal to 1, that is the number of component is equal to 1, then in such a system it is called as the one component system. So in this lecture we are going to discuss the water system. So all of you know that when we consider the water, it has the three phases, that is ice, water and water vapor. Chemically these three phases are H2O, that is a here in case of the water system. So number of component it is equal to 1. So here water system is the one component system. So system in which the chemical composition of every phase can be represented by a single substance is called as the one component system. So here again in case of the water there are three phases: ice, water and water vapor, and composition of these three phases can be expressed by single formula or single substance, that is the H2O. Therefore the water system, it is a one component system. Similarly carbon dioxide and the sulfur systems are one component system. Once again here when we consider sulfur, so here there are four phases in case of the sulfur: rhombic sulfur, monoclinic sulfur, liquid sulfur and sulfur vapors. Again here these four phases, they are chemically sulfur. So here the sulfur system is a one component system. Similarly here the carbon dioxide is also one component system. So here in this lecture we are going to discuss the water system. So here this is a phase diagram for the water system. So here water system, how the phase diagram is constructed. So here the phase diagram is it is a graph of pressure versus temperature. So this is a graph of pressure versus temperature for the water system. So again all of you know that in case of the water there are three phases, that is ice, water and water vapor. So here when we consider this diagram, that is a phase diagram. So here then there are three main part, that is the curves as well as the areas and the triple point. So here when we consider the curves, here there are two types of the curve: stable curves and the metastable curves. So here the curve AO, it is a stable curve, it is called as the sublimation curve of ice. Then second one is the curve OB, so it is the vapor pressure curve. Then here the curve OC, it is the melting point curve, and here there is only one metastable curve, that is the curve OD, it is called as the metastable curve. So here the first part is the curves, then the second one is the areas. So here the areas below AOB curve. So here the our area below the AOB, it contains the vapor phase only. Then here the areas BOC, here there is a water phase, and here the AOC, here there is a ice. So here the areas, and there is only one triple point, that is O. So what is the meaning of triple point? When the three phases are in equilibrium, such as the ice, water and water vapor, there is a equilibrium between the three phases. Such a point, it is called the triple point, and in this diagram O is the triple point. So here the information given by the phase rule about the water system can be represented graphically as shown in figure. And here the water system consists of the three phases, namely ice, water and water vapor. These three phases from the two phase equilibria. So here the liquid vapor equilibria. So here this is the liquid vapor equilibria. Then the second one is the solid vapor equilibria. So here the solid vapor equilibria, and the last one is the solid liquid equilibria. So here the solid liquid equilibria. So here there are three phases from the two phase equilibria. So here the phase diagram is constructed by plotting the vapor pressure of all phases at different temperature. Just we have discussed already it. So here the diagram consists of the curves. Again there are two types of the curve: stable curve and the metastable curves. So here the curves are separating the areas. So here the first curve is the AO, it is the sublimation curve of ice. So here in this diagram AO, it is the sublimation curve of the ice. Then next one is the curve OB, it is the vapor pressure curve, or it is the vapor pressure curve of the water. Then the curve OC, a melting point curve of ice or the freezing point curve of water. So these three are the stable curves in the diagram. There is only one metastable curve, that is OD. It is the vapor pressure curve of the metastable water. So here the curve OD. Here the vapor pressure curve for the metastable water. So here stable and the metastable curves. Then here the areas. So the three stable curves divided diagram into the three areas representing the three phases. Area below curve AOB, it is the vapor phase. Area AOC, it is the ice phase, and area BOC, it is the water phase. Already we have discussed this. So let us consider once again area AOB vapor phase, area BOC water phase, the area AOC, that is the ice or the solid phase. So these are the areas. Then triple point, the curve meet at the triple point O, which is called as the triple point. So O is the triple point in the diagram. So here description of the phase diagram of water. So here the first let us discuss the curves. So here the every stable and metastable curve represent the biphasic equilibrium. That means here two phases are in equilibrium. So here the first one is the curve AO, that is the stable curve. There is a equilibrium between the ice and water vapor. Then OB stable curve, there is a equilibrium between the water and the water vapor, that is a gas. Then the OC curve, here there is equilibrium between the ice and water. Then here the OD, this is a metastable curve, there is a equilibrium between the supercooled water and the water vapor. So here supercooled water we have discussed already. Supercooled water, it is possible to maintain the water in the liquid state below 0 degree Celsius by maintaining the certain condition, and such water it is called as the supercooled liquid. So here in the diagram the curve OD, it is a metastable curve, and there is a equilibrium between the supercooled water with the vapor. So here when we consider the curves, for locating the point on any curve, one has to know either temperature or the pressure. So here if we have to locate the point on the curve, so here either we have to mention or we have to specify temperature or the pressure, because for one temperature there is only one pressure, or for one pressure there is only one temperature. So along the curve temperature and pressure are interdependent, hence experimentally degree of freedom of any biphasic equilibria is 1. So let us consider the one example. So here when we consider the curve OB, so here there is a equilibrium between the water and water vapor. If we have to locate the point on the curve OB, either we have to specify the temperature or the pressure. So let us consider here this point. At this point there is only one temperature and only one pressure. So here at this point there is only one temperature and only one pressure. Either we have to specify or we have to mention the pressure or the temperature. So here we can say that along the curve temperature and pressure are interdependent, hence experimentally degrees of freedom of any biphasic equilibria is 1. So here the curves are mono or univariant. So once again all of you know that when the degree of freedom f is equal to 1, then it is called as the monovariant or the univariant. So this is a conclusion from the diagram. So then conclusion from the phase rule. So here our example is the water system. So water system is the one component system. So C is equal to 1, and here we are discussing about the curves. So curves are the biphasic, that means there are two phases. So P is equal to 2. So F is equal to C minus P plus 2. This is the mathematical equation for the phase rule. Substituting the value of the C and P in this expression. So C is equal to 1. So C is equal to 1 minus P is equal to 2. So 1 minus 2 plus 2. So this minus 2 plus 2 are cancelled and it is equal to 1. So theoretically curves are monovariant. That means here if we have to locate any point on the curve, either we have to specify temperature or the pressure. Then let us consider the curves one by one. So second one is the curve OB. The curve is known, this curve it is known as the vapor pressure or the vaporization curve because it gives the vapor pressure of the water at different temperature. This curve starts from the O and end at B, which is a critical temperature of the water, and its temperature is 374 degree Celsius, and beyond the point B, the critical temperature, the two phases liquid and vapor merge into each other. So here the curve OB. So here in the diagram curve OB, so here this is the critical temperature. So and its pressure is 218 atmosphere and the temperature is 374 degree Celsius. Then next one is curve OA. It is the vapor pressure curve of the ice and is called as the sublimation curve. So it represents the coexistence of the ice and vapor in equilibrium at different temperature. Thus, this curve shows variation of the pressure of ice with temperature, and this curve may extend from the absolute 0 to 0. So here the curve OA, it is called as the sublimation curve. Then here curve OC. So the curve OC, it is the melting point or the fusion curve of ice because it indicates the effect of pressure on the melting point of ice, and it represents the coexistence of the ice and the liquid. That means here ice and liquid, these two phases, they are in equilibrium. So curve OC has a negative slope, that is the OC line is inclined to the pressure axis, which indicate that the melting point of the ice is lowered by increasing of the pressure. Once again here the curve OC has the negative slope, that is the OC line is inclined to the pressure axis, which indicate that the melting point of ice lowered by increasing or increase of the pressure. The curve explain the skating on ice. So here the formation of the glaciers floating of ice on water, and why ice is lighter than the water, and why ice is lighter than water, and hoar frosting and the snow falling. This can be explained with the help of the curve OC. So these are the three stable curves. So let us consider the metastable curve. The metastable curve is OD. The curve is obtained by suddenly but carefully supercooling of the water below its freezing point. So such water, it is called the supercooled water, and again all of you know that the supercooled water, it is a highly unstable. So here when the small amount of the ice is added, or when we touch the supercooled water, immediately it solidifies. So it changes into ice even on slight disturbances, and the curve OD merges with the normal curve OA. So here this is the metastable curve. Then areas. So each area represents the single phase. Already we have discussed this. To locate the point in area, temperature and pressure must be specified. So here if we have to locate any point in the area in the phase diagram, so here we have to specify temperature as well as the pressure. So for the study of the single phase need selection of the temperature and pressure. So here the experimentally degree of freedom of each phase is 2. So here when we from the phase diagram, here we can say that if we have to locate any point in the area, we have to specify the temperature and the pressure. So the degree of freedom of the area, it is a 2. Then we can say that hence areas are the bivariant. So conclusion from the phase rule. In the area there is only one phase, so P is equal to 1, and we are discussing the water system. Again in case of the water system, C is equal to 1. So here substituting the value in the expression, F is equal to C minus P plus 2. So here C is equal to 1, P is equal to 1 plus 2. So here F is equal to 2. That means here conclusion from the phase rule and experimental conclusion, both the conclusions are same. So here the theoretically also degree of freedom for any phase is 2. That means for any area it is a 2, and here the both the conclusions are same. So here this is about the area. Then let us consider the next point, that is a triple point. So here in the diagram, O is the triple point where the three phases ice, water and vapor, they are coexist. So let us consider the diagram. So again here the O is the triple point. Here at this point, this ice, water and water vapor there is an equilibrium between these three phases at the temperature 0.0075 degrees Celsius and the pressure 4.58 millimeter. So, here in this diagram O is the triple point. So, here let us find out the degree of freedom for the triple point. So, here the O is the triple point where the three phases are in equilibrium. The point O has only one temperature 0.0075 degrees Celsius and the pressure 4.56 millimeter. So, here the temperature and pressure are non-variable. So, here these are the fixed value of the temperature and the pressure. At this temperature and pressure, there is a equilibrium between the three phases. So, here if one of them is changed, either pressure or temperature is changed, one or two phases disappear. Therefore, the triple point has degree of freedom 0. So, here it is a 0 variant or the non-variant. This is the conclusion from the phase diagram, because here the value of the temperature and pressures are fixed. So, here triple point, it is a 0 variant or it is a non-variant. So, let us find out the value of the degree of freedom from the phase rule. So, again water system C is equal to 1. At triple point, three phases are in equilibrium, that is why P is equal to 3. So, here F is equal to C minus P plus 2, substitute in the value of the C and P here, finally the value of the F is equal to 0. So, theoretically also degree of freedom of the triple point, it is equal to 0. So, here this is about the phase diagram, and in the phase diagram we have discussed the curves, areas and the triple point for the water system. Then here the curve OA, OB and OC are almost linear in the diagram. The slope of each line is equal to the dP by dt, that is the change in pressure with respect to T. So, here dP by dt, it is the slope of the line, and from the slopes and the Clapeyron equation is dP by dt is equal to m is equal to delta H by T into delta V. So, here delta H, it is called as the change in enthalpy, it is called as the change in enthalpy. Then here the T is the temperature, delta V change in the volume. So, here it is possible to evaluate heats of vaporization from the curve OB. Then here the heats of sublimation from the curve AO and heats of fusion from the curve OC at different temperature. So, this is the use of the phase diagram. So, here with the help of the phase diagram as well as this Clapeyron equation, it is possible to find out the heat of vaporization, heat of sublimation as well as the heats of fusion. So, friend, this is about the water system, and water system is the one component system. In the next lecture, we are going to discuss again another example of the one component system, that is the sulfur system. Thank you.